Welcome to Astronomy Daily. I'm Anna, and we have a great lineup of space discoveries and developments to share with you today. From ancient lunar canyons formed by catastrophic impacts to spectacular galactic collisions creating cosmic ripples and groundbreaking missions exploring our solar system, we'll journey through some of the most fascinating recent developments in space exploration and astronomy. Our stories today will take us from the moon's mysterious South Pole to the far reaches of space, where the spectacular Bullseye Galaxy shows us the aftermath of an incredible cosmic collision. We'll also check in on several exciting space missions, including Blue Origin's latest achievement and NASA's ongoing explorations of our cosmic neighborhood. A lot to cover, so let's kick things off with our own moon. A fascinating new study has revealed the dramatic origin story of two enormous canyons near the moon's South Pole. These massive structures, known as Vallis Schrodinger and Vallis Planck, were carved out in less than 10 minutes by an extraordinary cosmic event that occurred 3.8 billion years ago. According to research published in Nature Communications, it all began with a massive impact near the lunar South Pole. This collision sent a curtain of rock flying away from the impact site, and when these rocks came crashing back down, they struck the lunar surface with devastating force. The energy released was truly astronomical, about 130 times greater than Earth's entire nuclear weapons inventory. These falling rocks created what planetary geologist David Kring describes as a staccato-like series of impacts, bang, 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 that carved out two incredible canyons. To put their size in perspective, while the Grand Canyon reaches depths of 1.9 kilometers, these lunar canyons plunge as deep as 3.5 kilometers into the moon's surface. They stretch for about 270 and 280 kilometers in length, cutting straight lines across the lunar landscape. What makes this discovery particularly significant for future lunar exploration is its location. The impact site lies about 125 kilometers from where NASA's Artemis astronauts plan to land. Initially, scientists worried that the impact might have buried some of the moon's oldest rocks, potentially dating back to its formation 4 billion years ago, under debris. However, the team's analysis revealed some good news. The impact appears to have thrown material primarily northward, away from the planned exploration zone. This means that when astronauts arrive, they should still have access to these ancient rocks, offering an unprecedented opportunity to study the earliest chapter of the Earth-Moon system's history. If we could stand on the lunar surface today, we'd be looking at what Kring calls one of the most dramatic landscapes in our cosmic neighborhood, a testament to the moon's violent past and a window into the powerful forces that shaped our solar system. And some good news today. Blue Origin has just achieved a significant milestone in space research with their latest New Shepard launch from their West Texas facility. The mission, designated NS-29, wasn't just another routine flight. It marked the company's first successful attempt at simulating lunar gravity conditions in space. The launch saw New Shepard reach an impressive altitude of 105 kilometers above sea level. What made this flight unique was what happened after the capsule separated from its booster. Using reaction control thrusters, the capsule was commanded to spin at 11 revolutions per minute, creating lunar gravity conditions inside for approximately 2 minutes. This capability represents a major breakthrough for lunar research. As Phil Joyce, Blue Origin's Senior Vice President for New Shepard, explained, it provides researchers with an invaluable opportunity to test lunar technologies at a fraction of the cost of actual moon missions. Scientists can now rapidly iterate and test their experiments in lunar-like conditions, dramatically accelerating the development process. The mission carried 29 different payloads, with 17 of them provided by NASA through their Flight Opportunities program. These experiments covered crucial areas for future lunar exploration, including resource utilization, dust mitigation, advanced habitation systems, and various spacecraft technologies. One payload was even mounted on the exterior of the booster to test its response to space conditions. While there was a minor issue with one of the 3 parachutes during descent, the capsule landed safely as it's designed to operate with just 2 parachutes. The successful completion of this mission opens up exciting new possibilities for lunar research and development, providing a crucial stepping stone toward sustainable lunar exploration and establishing a permanent human presence on the moon. The achievement marks a significant advancement in our ability to prepare for future lunar missions, offering researchers a reliable platform to test and refine their technologies before deploying them on the moon itself. Next up today, talk about a cosmic bullseye. The Hubble Space Telescope has captured something truly remarkable. A galaxy sporting not one, not two, but 9 distinct ring-shaped ripples in its structure. This extraordinary cosmic object, formerly known as LIDA 1313424, but nicknamed the Bullseye Galaxy, lies about 567 million light-years away in the constellation Pisces. This discovery was completely serendipitous. Yale University researcher Imad Pasha spotted these unusual rings while reviewing a ground-based imaging survey, and the finding immediately demanded closer investigation. When the team took a closer look using Hubble's advanced camera for surveys, they were able to spot 8 distinct rings, with a 9th ring identified using data from the Keck Observatory in Hawaii. What caused this remarkable pattern? Well, imagine throwing a rock into a pond. That's essentially what happened here on a galactic scale. A smaller blue dwarf galaxy plunged right through the heart of the larger galaxy about 50 million years ago, creating these spectacular ripples in space. Even now, though the galaxies are separated by 130,000 light-years, they remain connected by a thin trail of gas. The Bullseye Galaxy itself is quite a sizable target, spanning about 250,000 light-years. That's 2.5 times wider than our Milky Way. The impact event caused galactic material to move both inward and outward, triggering multiple waves of star formation along these ripples, creating exactly the pattern that theoretical models had predicted. What makes this discovery particularly exciting is that it's the first time we've seen so many rings in a single galaxy. Previous observations of similar galactic collisions only showed 2 or 3 rings at most. The timing of this observation is particularly fortunate, as there's only a brief window after such an impact when a galaxy would display so many distinct rings. This remarkable observation not only confirms long-standing theoretical predictions about galactic collisions, but also gives us a preview of what might happen when galaxies merge, something our own Milky Way will experience billions of years from now when it collides with the Andromeda Galaxy, though that encounter is expected to be far more complex than this relatively straightforward cosmic bullseye shot. In more moon news, an exciting new mission is preparing to head to the moon as SpaceX readies the launch of the Lunar Trailblazer orbiter, scheduled for February 26th from NASA's Kennedy Space Center. This university-led mission has a fascinating objective: to pinpoint the locations of ice and liquid water trapped within lunar rocks. The spacecraft, weighing about 440 pounds, has been built by Lockheed Martin using their innovative Curio platform, a new small-sat architecture designed to make deep space exploration more cost-efficient. The probe comes equipped with 2 deployable solar arrays and carries 2 primary scientific instruments: the high-resolution volatiles and minerals moon mapper from JPL and the lunar thermal mapper from the University of Oxford. What makes this mission particularly interesting is its planned observation strategy. The Lunar Trailblazer will peer into permanently shadowed regions of the moon, searching for micro-cold traps smaller than a football field. It will also collect measurements at various times of day over sunlit regions to understand how water signatures might change as surface temperatures fluctuate by hundreds of degrees during a lunar day. Following its launch aboard the Falcon 9, where it will share the ride with Intuitive Machines' Athena lunar lander, the spacecraft will take between 4 to 7 months to reach lunar orbit. Once there, it's planned to operate for at least a year, systematically mapping and studying the moon's water distribution. This mission represents an important step in understanding how water works on the moon, knowledge that could prove crucial for future lunar exploration and potential human settlement. After completing its scientific mission, the spacecraft will conclude its journey with a planned impact on the lunar surface, a process officially termed as surface disposal. The Lunar Trailblazer is part of NASA's Small Innovative Missions for Planetary Exploration program, and in a unique educational component, it will be operated by students from both Caltech and Pasadena City College at the Caltech-based Infrared Processing and Analysis Center. NASA's Europa Clipper mission has hit an early milestone on its ambitious journey to Jupiter's icy moon Europa, marking progress just 3 months after its launch from Kennedy Space Center. While the spacecraft still has an incredible 1.6 billion miles ahead of it before reaching Jupiter's orbit in 2030, it's already providing valuable data from its current position, 53 million miles from Earth. The mission team recently received the spacecraft's first images of deep space, captured by its star tracker cameras. These specialized imagers act like a celestial compass, helping mission controllers precisely determine the spacecraft's orientation, crucial for keeping its communication antennas pointed toward Earth. The captured star field shows tiny pinpricks of light from stars between 150 to 300 light-years away, including bright stars from the constellation Corvus. The spacecraft is currently racing through space at an astonishing 17 miles per second relative to the Sun and is approaching its first major navigational milestone, a Mars flyby scheduled for March 1st. This carefully planned maneuver will use the red planet's gravity to give the spacecraft an additional boost on its long journey to the Jupiter system. Once it reaches its destination, Europa Clipper will conduct 49 close flybys of Europa, using its suite of 9 scientific instruments to study the moon's composition, geology, and the mysterious ocean that lies beneath its icy crust. This comprehensive investigation will help scientists determine whether Europa's subsurface ocean might harbor conditions suitable for life. The successful checkout of the star trackers represents an important early step in ensuring all systems are functioning as intended after launch. While the spacecraft's main science cameras remain safely behind their protective covers for at least the next 3 years, these engineering milestones are building confidence in the mission's ability to accomplish its ambitious scientific goals when it finally arrives at Jupiter's intriguing icy moon. Have you ever thought about this? A fascinating new study is asking a compelling question. If there are alien civilizations out there with technology similar to ours, how far away could they detect signs of Earth's existence? This research, led by Sophia Sheikh from the SETI Institute, takes a unique approach by examining our own technological footprint from an outsider's perspective. Instead of speculating about advanced alien civilizations, the team focused on what an alien civilization with Earth 2024 level technology could detect. They analyzed various technosignatures we're currently producing, from radio transmissions to satellite signals, and even city lights and atmospheric pollution. The results paint an interesting picture of our cosmic visibility. Our most detectable signature comes from our planetary radar systems, like the former Arecibo Observatory, which could be spotted from up to 12,000 light-years away. That's roughly the distance to the Tadpole Nebula, quite a considerable reach into our galaxy. The next most visible signs would be signals from NASA's Deep Space Network, detectable from about 100 light-years away. But most of our technological signatures, including our LTE signals, atmospheric pollution, and laser emissions, would only be detectable from within about 4 light-years, approximately the distance to our nearest stellar neighbor, Proxima Centauri. What's particularly intriguing is how these findings might inform our own search for extraterrestrial intelligence. The research suggests that despite ongoing debates in the SETI community, focusing on radio waves remains our best bet for detecting other civilizations, as they outperform other technosignatures by a factor of 1,000 in terms of detection distance. The study also raises thought-provoking questions about how we're presenting ourselves to the cosmos. Our technological signatures could tell potential observers quite a bit about our society, from how we organize ourselves to our relationship with our environment. It's a cosmic mirror that reflects not just our technological capabilities, but also who we are as a civilization. That brings us to the end of another fascinating episode of Astronomy Daily. I'm Anna, and I hope you've enjoyed exploring these incredible stories from across the cosmos with me today. From ancient lunar canyons to rippling galaxy collisions, and from water hunting spacecraft to our own cosmic detectability, it's been quite a journey through space and science. If you want to stay up to date with all the latest developments in space and astronomy, head over to astronomydaily.io. There you can sign up for our free daily newsletter and access our constantly updating newsfeed. You'll also find all our past episodes available for listening anytime. Don't forget to join our growing community on social media. You can find us by searching for Astro Daily Pod on Facebook, X, YouTube, and TikTok. We're sharing amazing space images and breaking news content every day. Until next time, keep looking up and wondering about the mysteries of our universe. This has been Anna with Astronomy Daily.